right, let's talk about percentage yield in this video. So we've learned all about calculations, about stoichiometry, about different reactions. And using those calculations, you can predict how much of a certain product could be produced if that reaction is performed in real life. However, what you might often find is that when you actually do that reaction, the answer that you get might not be exactly what you calculated, right? And we can measure the accuracy of your performance, your lab performance, by looking at percentage yield. And percentage yield looks at two different numbers. One is the actual yield. So this is how much of product you produce when you actually performed this reaction in real life. Whereas the theoretical yield, which is the other number, is the number or the amount of your product that you calculated. So theoretical is almost like an ideal situation. So ideally, if everything in your lab is done perfectly, how much of that product could you expect to make? So the formula for this looks a bit like this. So percentage yield is equal to the actual yield over the theoretical yield times 100%. And now usually actual yield and theoretical yield are measured in grams, so that grams would cancel out, and then you end up with a number that is a percentage. Again, think of this as an assessment for how well this lab was performed in real life. It is possible that sometimes when you do a lab, the product, the actual yield, might be greater than the theoretical yield, right? So there are instances where that has happened. Again, when you calculate your percentage yield, it would just be that it is greater than 100%. So it is possible for that to occur, but that's not something that is ideal. We don't want a percentage yield that's greater than 100% because that means that something has gone incorrectly. So let's take a look at how we would calculate percentage yield depending on the situation that we're in. So in this first example, the question says, determine the percentage yield if 5.50 grams of nitrogen monoxide is actually formed and the theoretical yield of nitrogen monoxide is 25.0 grams. Now, in this question, the phrasing really helps us out because they tell us which is the actual yield and which is the theoretical yield, right? It tells us that 5.50 grams of nitrogen monoxide is actually formed. So that in itself is my actual yield. So 5.50 grams. I'm not going to write the formula out because you have that in your notes. So I know that my actual yield goes in the numerator spot, 5.50 grams. And they very, very clearly tell you that the theoretical yield is 25.0 grams. So 25.0 grams. So when I divide the actual yield by the theoretical yield and multiply it by 100%, I'm going to get 22.0%. This is the percentage yield of this particular question. All right, let's take a look at example number 2. In this case, it says if 2 of 20.0 grams of glucose reacts to produce 1.40 grams of ethanol, what is the percentage yield of this reaction? Now, this is where you really have to understand what's happening in the question. You're starting off, so first of all, this is glucose, and this is ethanol. So they're telling you that if you start off with 20.0 grams of glucose, it produced 1.40 grams. So this is the actual yield. Now, if you notice, there's no theoretical yield mentioned in the question. However, you have the mass of your reactant. You've got a full balanced reaction. So it is up to you to find your theoretical yield using your calculations. And because we've learned about stoichiometry, this becomes a little bit easier. So I've got 20 grams of glucose. I need to figure out the theoretical yield. How many grams of ethanol could theoretically be produced if I have 20.0 grams of glucose? So I'm going to use my stoichiometry. So 20.0 grams of glucose, C6H12O6. And I'm going to first need to convert to moles, right? So I'm going to go from grams to moles. I'm going to use the mole ratio to find the moles of ethanol. And then I'm going to use my molar mass to go back to grams. So that's sort of my game plan here. So if I have 20.0 grams of ethanol, I'm going to need to use my 20.0 grams of glucose. I'm going to need to use my molar mass to find the moles of glucose. So 1 mole of C6H12O6 is equal to my molar mass when I take into account the elements and how many of each element there are. I'm going to get 180.18 grams of C6H12O6. Right? So now I've canceled out my units of grams of glucose, and I've now found my moles of glucose. Now again, I'm here at this step. I need to figure out the moles of ethanol. So I have to use my mole ratio. And using my mole ratio, I know that this is a 1:2 ratio. So for every 1 C6H12O6, there are 2 C2H5OH. So for every 1 mole of C6H12O6, there are 2 moles of C2H5O6. Again, this causes this to cancel out. And now I've got my unit in moles of ethanol. Again, I need to figure out the grams of ethanol because I'm trying to find the theoretical yield. So let's use a different color. So for every 1 mole of ethanol, C2H5OH, there are 46.08 grams of ethanol. Right, so what I've done here, I've used stoichiometry to try and identify what the theoretical yield is going to be. Now, this you might have to do in situations where your theoretical yield is not given in the question, and that might happen quite often, right? So let me type in all of these numbers into my calculator. 20.0 divided by 180.18 times 2 times 46.08. Now, this gives me a number, and this number has the unit of grams of C2H5OH, right? That makes sense. I'm trying to find theoretically, if I started off with 20.0 grams of glucose, how many grams of ethanol will I find? Now, these numbers in my question, they both have 3 sig figs, so my answer should also have 3 sig figs, 10.2 grams of ethanol. This is how many grams would, theoretically, that is how many grams of ethanol that would be produced. Now, the question is not asking me for theoretical yield, it's asking me for percentage yield. So I have to take my actual yield from the question, 1.40 grams, divide by my theoretical yield that I figured out in my calculations, times 100%. Right, so when I do this particular calculation times 100, I will get 13.7%. So this is the percentage yield for this reaction. So the two types of reactions, the two types of questions that we've done, one where you're given both the actual yield as well as the theoretical yield. The second type of question where you're given the actual yield in the question, but you have to figure out what the theoretical yield and then find the percentage yield. Okay, that's pretty much it.